Hey everybody, welcome back to my channel. This is WarDogSec, and I'm back with another video. Today's video, we're going to continue on with the Advent of Cyber 2023 event from TryHackMe. This is day number 14, Machine Learning, the little machine that wanted to learn. Now, if you're new here, please consider hitting that subscribe button with the notification bell. If you're enjoying the content, hit that like button and comment below your thoughts and opinions on the information shared. Without further ado, let's go ahead and get into it. We are going to skim through a lot of this information here, but I highly recommend that you go to the room and finish reading through all the information yourself. Learning objectives. What is machine learning? Basic machine learning structures and algorithms using neural networks to predict defective toys. All right, let's go ahead and get into the introduction. Over the last decade, there has been a massive boom in artificial intelligence, AI, and machine learning (ML) systems. Just in the last couple of years, the release of ChatGPT has taken the world by storm. However, how these systems actually work is often shrouded in mystery, leading a lot of snake oil tactics. Nice. And this task, we will provide you with a glimpse into the world of machine learning to help demystify this incredible, interesting topic. We will create our own neural network that can be used to detect defective toys. Before we can create our own AI, we need to learn some of the basics. First of all, let's discuss the two terms. The term AI is used in broad strokes out in the world, often incorrectly. We have to be honest with ourselves. AI can't just be a bunch of if statements. A better term to use is machine learning. ML refers to the process used to create a system that can mimic the behavior we see in real life. This is because there is intelligence in real life and its structures. The field is incredibly broad, but here are a couple of popular examples. It talks about generic algorithm, particle swarm, neural networks. Continuing on here, it says there are many more ML structures, but we'll stick to neural networks for this task as they are the most popular. Learning styles. First on our list of ML basics is to cover neural networks learning style. In order to train our neural network, we need to decide how we'll teach it. While there are many different styles and subsets of styles, we'll only focus on the two main styles for now. Supervised learning. All right, it says in this learning style, we guide the neural networks to the answers we want to or want it to provide. Unsupervised learning is in this learning style, we take a bit more of a hands-off approach and let the neural network do its own thing. Basic structure, next on our ML basics to learn is the basic structure of a neural network. Sticking to the very basics of ML, a neural network consists of various different nodes, neurons, that are connected as shown in the animation below. So be sure to check this out. As shown in the animation, the neural network has three main layers. Input layer, this is the first layer of nodes in the neural network. Output layer, this is the last layer of nodes in the neural network. Hidden layer, this is the layer of nodes between neural and network's input and output layers. Continuing on here, it starts talking about inputs are not directly added. Instead, they are multiplied by weight value first. The additions output is not directly transmitted out. Instead, the output is first entered into what is called an activation function. Feed forward loop. The feed forward loop is now or is how we send data through the network and get an answer on the other side once our network has been trained. This is the only step we perform. At this point, we stop training and simply want an answer from the network. To complete one round of the feed forward step, we have to perform the following. All right, and it starts talking about normalizing all the inputs, feed the inputs to our nodes, and the input layer, propagate the data through the network, read output from the network. Back propagation, when we are training our network, the feed forward loop is only half of the process. Once we receive the answers from our network, we need to tell it how close it was to the correct answer. This is back propagating step. Here we perform the following steps. 1. Calculate the difference in received outputs versus expected outputs. 2. Update the weights of the nodes. 3. Propagate the difference back to the other layers. says once all weights have been updated, we can run another sample of data through our network. We repeat this process with all our samples in order to train our network. And it starts talking about data split or data set splits. The last topic to cover before we can build our network and data is data splits, or sorry, data set splits. Let's use an analogy to explain this. Let's say your teacher constantly tells you that 1 plus 1 equals 2 and 2 plus 2 equals 4. But in the exam, your teacher asks you to calculate 3 plus 3. The answer here is, have you just learned what the answer is, or did you learn the fundamental principle required to get the answer? In short, you can overtrain yourself by learning the answers instead of learning the required principle itself. The same thing can happen with neural networks. All right, and it starts explaining some more things here. It says to perform this validation, we have to split our data set into 3 data sets below. Training data, validation data, testing data, putting it all together. So now that we have covered the basics, we are ready to build our very own neural network. Start the machine in the right corner. It will show in split screen, yada, yada, yada. You are provided with the following files, detector.py, dataset underscore train.csv, dataset underscore test.csv. Our first step is to complete the data or detector.py script. Let's work through the initial code. It has already been added for you in the script as shown in the snippet below. First, let's go check out these questions before we start going through this practical application portion. All right, I'm just going all the way down here. Keep going. All right, now before we get on to the questions, try to answer them yourself and then come back to the video. But let's go ahead and take a look at the questions here. All right, what is the other term given for artificial intelligence or subset of AI meant to teach computers how humans think or nature works? As discussed above, if you read through it, it was machine learning. The second one is what ML structure aims to mimic the process of natural selection and evolution, genetic algorithm. What is the name of the learning style that makes use of labeled data to train an ML structure, supervised learning? What is the name of the layer between the input and output layers of a neural network? Hidden layer, as discussed above. And it says, what is the name of the process used to provide feedback to the neural network on how close its prediction was? Back propagation. And it wants us to find the flag here. What is the value of the flag you received after achieving more than 90% accuracy on submitted predictions? So let's go ahead and try to find this flag. Okay, now we're going to go through and make some modifications to this detector.py script. All right, as you can see, I've already navigated to the correct directory. I use cat on it, so you can take a look at it through cat, read through it, and also have it pulled up over here in Nano so we can start editing it. So let's get down to it. So the first step is to complete the detector.py script. Let's work through the initial code. As you can see there, the code's already in there. We just have to add a few things. Be sure to read through all of this so you understand what it's doing here. It says let's work through this, what the code does. Number one, the first few lines are all the library imports that we need for our neural network. We will make use of pandas to read our data sets and skikit learn for building our neural network. Not sure how you pronounce that, but whatever. Number two, next we load the data sets. In our case, there is a training and testing data set. While we have the labels for the training data set, we don't have them for the testing data set. So while we can perform supervised learning, we will only know our neural network's true performance once we have uploaded our predictions for review. Three, once the data is loaded, we need to make sure that all inputs are numerical values. One of our data types is the toy's color scheme. In order to provide this data to our network, we will encode the colors to numbers. For lastly, we load the data. Variable X is used to store our training dataset together with its labels stored in variable Y. Lastly, test underscore X stores the dataset or testing dataset that we will use to perform the predictions on. All right, so now we're going to start adding some code to creating data sets. This is the first one you're going to do. You're going to locate this line here. As you can see, I've already done it. So you're going to copy this information here and you're going to input it down here into that appropriate section. It says this will split our training data set into two. Training underscore X contains the training data and validate underscore X. And you can see the rest there. The normalizing data, you're going to do the same thing. You're going to copy and paste this into the correct area in here, which I've already done. So I'm going to scroll down a little bit here. There you have it right here. And it says, as you can see from the lines of codes, we cannot cheat by determining the normalization on either the validation or test data sets. It says train the neural network. Finally, we can train our neural network. First, we will create our classifier with the following code and locate this one here. It says insert classifier code here, which I've already done, as you can see here. So you can copy and paste that over there. It says you can find more information on the specific classifier here, so be sure to check out this link. Here's a bit of an explanation of what the values are doing. Solver equals quote. It says this is the algorithm used to update the weights. Alpha, the alpha value is used for the regularization of the neural network. Hidden underscore layer underscore sizes. This tells us the structure of the hidden layers in our neural network. Max iter. This sets a cap on the number of iterations we can train our neural network before it's forcibly stopped. Okay, let's continue on here. Next, we can train our classifier. So we're going to copy, paste this again under the appropriate section, and I already have it in here. As you can see there. Right, and then it says when this step is complete, we have successfully trained our neural network. That's good. And it says validate our neural network. Next step is to validate our neural network. To do this, we can ask the neural network to predict the values based on the validation data set with the following code added after the insert classification validation prediction code here line. So you can copy and paste that over. As you can see, I've already done it right here. And then the last one we'll do here is this one, the saving the poison toy pipeline. So be sure to do the same thing here, copy and paste that over. I've already done it here, so I'm gonna scroll down towards the bottom. There we go. And that's it. Now let's go ahead and try to run this. So I'm gonna go ahead and save it in Nano. So I'm gonna hit Control O, save it, and then exit out of here. Let's move over here. No, we don't need to. Okay, so I'm gonna do Python 3 on it to run it. Let's go ahead and see what it does. Now, this may take a couple minutes, so let's go ahead and pause and skip ahead. After a few minutes, it should have ran and did its thing here. Got your predictions. You can see there, total correct, total incorrect, network accuracy 91.75. It says now we will predict the testing data set for which we don't have answers for. Went through, did all that, and it says saving predictions to a file. Predictions are saved. This file cannot be uploaded to verify your neural network. And that's what it wants us to do here. It says the predictions will be saved to a file. Upload your predictions here to see how well your neural network performed. If your accuracy is above 90%, you'll be awarded a flag. So let's go ahead and do that. I already have it pulled up here. So hit browse, neural network, and then predictions, and then upload. Awesome. I got the flag here because my accuracy is above 90%. Now, I believe that is it for this room. It says if you enjoyed this room, we invite you to join our Discord server for ongoing support, exclusive tips, and community of peers to enhance your Advent of Cyber experience. Now, this AI machine learning stuff is going to become more and more prevalent out there, especially when it comes to like antivirus, endpoint protection, EDR tools, what have you, all kinds of cybersecurity tools. There's a lot of things you can apply this to, and it outlines some of the applicability stuff here. So you make sure to read through all that and understand what's going on here, because this will probably be the future of cybersecurity. This is where it's leaning. Everyone's talking about AI and stuff. It's all in the news. So be sure you're trying to stay abreast to what information is coming out. Now, if you enjoyed this video and you're new here, hit that subscribe button with the notification bell. If you enjoyed the video, hit the like button, comment below and your thoughts and opinions. As always, thank you for watching. Have a nice day, and I will see you later.